Hello friends, this is Infinity Vision, myself Gurleen Singh, and today we'll be discussing the second chapter, which is inverse trigonometric functions, and we'll be starting with the first exercise, which is a very basic one. So let's start with the first question. So the first question is, find the principal values of the following. So first one is sine inverse minus half. So first of all, you need to tell me what is the range of sine inverse x. So this is minus pi by 2 to pi by 2, right? So sine inverse x lies between minus pi by 2 to pi by 2. So this is sine inverse minus half, which can be written as sine inverse minus half is equal to sine inverse minus sine pi by 6. Now half can be written as sine of pi by 6, which is sine of 30 degrees. So this becomes sine inverse sine minus pi by 6, which is equal to minus pi by 6. Since sine inverse x lies between minus pi by 2 to pi by 2. So this is basically how we solve such question, okay? Or there's one other method. You can put sine inverse half is equal to some constant, let's say y, okay? And then you calculate the value of y. So that's one way of doing it, okay? So let's start with the next question now. So this answer will be equal to minus pi by 6. So moving on to the next problem, it is find the principal values of cos inverse root 3 by 2. So first of all, cos inverse x, this lies between 0 to pi. Okay, first this thing should be clear. Now, if cos inverse root 3 by 2 is equal to, let's say, y, then we get cos y is equal to root 3 by 2, which is nothing but cos of pi by 6, right? So therefore, clearly from here, we get y is equal to pi by 6. So the answer to this question will be pi by 6. So this is simply how we solve such questions, okay? No need to worry about anything, just put this equal to y and then calculate the value of y from this formula, cos y is equal to root 3 by 2. So this will be equal to pi by 6. So let's start with the next one now. So next one says, find the principal values of cosecant inverse 2. So cosecant inverse x, this lies between minus pi by 2 to pi by 2 except 0, right? So you have to find the value of cosecant inverse 2. Let's say this is equal to y. Therefore, cosecant y is equal to 2 is equal to what? Cosecant pi by 6. So it's again a pretty similar one, right? That cosecant becomes 2 when theta is equal to pi by 6, okay? So therefore, from here y is equal to pi by 6. So therefore, this value equals pi by 6. Clear? Moving on to the next problem. The next question is tan inverse minus root 3. So tan inverse x lies between minus pi by 2 to pi by 2, and not including minus pi by 2 and pi by 2, because at these two it becomes not defined, right? So if tan inverse root 3 is equal to y, this implies that tan y is equal to root 3. So tan y is equal to tan pi by 3. Sorry, this is minus root 3. Okay, so this is tan of minus pi by 3. So y is equal to minus pi by 3. So therefore the answer to this one will be minus pi by 3. Right? So after this we'll see the next problem, the fifth one, which is inverse minus half. So first we know that cos inverse x lies between 0 to 2 pi. Sorry, 0 to pi. Right? Now this is cos inverse minus half. So if cos inverse minus half is equal to y, then cos y is equal to minus half. So for what value between 0 to pi can we get minus half? So this will be cos pi minus pi by 3. Right? So at cos 2 pi by 3 we'll get the value minus half. Right? In all such cases where you are getting negative, you have to do pi minus theta, right? Because cos of pi minus theta is minus cos theta, right? So from here we get y is equal to 2 pi by 3. Pretty simple, right? Moving on. The next problem is tan inverse minus 1. So we know tan inverse x lies between minus pi by 2 to pi by 2. So therefore if tan inverse minus 1 is equal to y, then tan of y is equal to minus 1, right? So this is possible at tan of minus pi by 4, right? Tan minus 45 degrees. So therefore y is equal to minus pi by 4. So this value is minus pi by 4. So these questions are pretty simple as long as you remember the range of all of these expressions, sine, cos, tan, all of them, then it's pretty easy. Now we'll see the next problem. Let's see which inverse trigonometric ratio is there. So we have secant inverse. So just remember that secant inverse x lies between 0 to pi minus pi by 2. So this question is pretty simple one. Secant inverse 2 by root 3 is equal to y. 2 by root 3 is equal to secant y, right? So secant y is equal to what? So when do we get the value of secant 2 by root 3? When we get the value of cos root 3 by 2, right? And that is pi by 6. So this value will be equal to pi by 6. In the eighth one it is cot inverse root 3. So we know that cot inverse x lies between 0 to pi, right? Open brackets. So therefore if cot inverse root 3 is equal to y, then cot y is equal to root 3. And when is this equal to root 3? Again pi by 6. So just check out in how many questions the answer is pi by 6. Cos inverse minus 1 by root 2. So cos inverse x lies between 0 to pi. So therefore cos inverse minus 1 by root 2 is equal to y gives you cos y is equal to minus 1 by root 2 is equal to cos pi minus pi by 4. So therefore y is equal to 3 pi by 4. So the answer to this question will be 3 pi by 4. Let's see the next problem. Cosecant inverse minus root 2. So cosecant inverse x lies between minus pi by 2 minus 0, right? Because if you see 0, then when x this thing is equal to 0, that is only possible when sine theta is 0. So that is not possible in this case, because if sine theta is 0, cosecant will become not defined. So this is not defined at 0. So therefore cosecant inverse minus root 2 is equal to y gives you cosecant y is equal to minus root 2. Therefore cosecant y is equal to cosecant minus pi by 4, right? So therefore this thing is equal to minus pi by 4. So next is tan inverse 1 plus cos inverse minus half plus sine inverse half. So tan inverse 1, we know this is equal to pi by 4. What is cos inverse minus half? We can simply use pi minus pi by 3. And for this we can simply use minus pi by 6. So you just have to add all these. So first one is pi, second one is pi minus pi by 3, and third one is minus pi by 6. So this is pi by 4, 2 pi by 3, minus pi by 6. Take the LCM 12, 3 pi by 4 plus 8 pi minus 2 pi. So solving this you get 9 pi by 12 or 3 pi by 4. So I reckon this is correct. Yes, this is correct. So the answer is 3 pi by 4. So you just have to simply solve each of them and then put the values. So let's see the next question, the 12th one. Before solving this question, just see there's a little mistake here. This should be cos inverse half plus 2 times sine inverse half. So what is cos inverse half? This is equal to pi by 3 plus 2 times this is pi by 6. So we get pi by 3 plus pi by 3, which is 2 pi by 3. So this is the answer. Moving on to the next problem. We have if sine inverse x is equal to y, then y lies between which and which. So if sine inverse x, we know the range of sine inverse x is minus pi by 2 to pi by 2. So the answer will be B. So this is a fact-based problem, formula-based, which we need to remember. The range of this sine inverse x is minus pi by 2 to pi by 2. Let's move on to the last one. Tan inverse root 3 minus secant inverse minus 2. So tan inverse root 3 will be equal to pi by 3, and secant inverse minus 2, this will be equal to pi minus pi by, so it should be 3. So if you solve this, you get 2 pi by 3 minus pi by 3. So this will be the answer. B part minus pi by 3. So basically all these questions conclude the first exercise. Okay, we are done with the first exercise and we'll be back shortly with the second exercise of inverse trigonometric functions. So stay tuned and thank you for watching the video. Stay tuned with Infinity Vision.